So we're going to solve the following questions. And the first one reads, given that A and B are sets, simplify the following if possible. So to simplify this, we can see that we have X union Y intersect, and then we have X union Y complement. From here, for us to simplify, we see that we have X union and X union in both of these sets. So we can factor out that X union, and then we remain with Y. The sign in between is intersection, and then Y complement. Okay, so we deal with this part here, which is Y intersect Y complement. So Y intersect Y complement is just equal to the empty set. You can see that graphically. If we draw our Venn diagram, we say that's the set Y. So inside here is the set Y. Outside there is its complement, and the two do not intersect anywhere. So meaning that it is empty. Thus we have X union the empty set. But any set union the empty set is just that set. So this gives us X. So this simplifies to X. Okay. Next here we have, given that the root of the square root of 3 is an irrational number, show that 1 minus root 3 is also an irrational number. So to do this first, we shall prove by contradiction, where we first assume that this number is actually not irrational, but it's rational instead. So I say, suppose 1 minus root 3 is rational, then it can be expressed in the form A over B, where B is not equal to 0, and A and B are, or A and B are coprime, or A and B have no common divisors, Okay, so this is the supposition that we make, or the assumption that we make first. So this means we're going to have A minus root 3. We're saying this can be expressed in the form A over what? A over B. So now I take the other side, and I'll have it becomes negative. The additive inverse of positive 1 is negative 1. So we have A over B minus 1. Then I can multiply by the negative both sides, such that I have square root of 3 is equal to this here. I'll have A over what? So I'll have 1 minus A over B. I have square root of 3 is going to be equal to, making this into a single fraction. I have over B, then I have B minus A. So now B minus A is an integer. So B minus A is an integer, and B also is an integer. And then if we have an integer over an integer like this as a fraction, it means this whole thing here is rational. So since we've expressed this here in the form A over B, so A minus A over B is just an integer. So it being an integer means that makes this fraction here to be rational. But then, according to the question, we're given that the square root of what? Square root of 3 is irrational. So we know that this is irrational. So now this here is going to be a contradiction, because an irrational number cannot equal what? A rational number. So we conclude, since square root of 3 is irrational, that we know from the question, it means that this here, square root of 2b minus square root of 3 equal to b minus a over b, this cannot be equal. And if they cannot be equal, it means that 1 minus root 3 is not rational. Instead, it's going to be what? Irrational. Instead, it's going to be what? Irrational. And like that, that's how you show that it is what? It is an irrational number. Okay, so next here we have this question which tells us to express the complex number this here into the form a plus ib. So what do we do? So we have the first part, which is 1 plus 2i over 1 minus I. So what we do, we must rationalize this. So we will rationalize by multiplying by the conjugate. So this is going to be multiplied by 1 plus I, even there 1 plus I. And I'm going to have this is going to be equal to 1 multiplied by 1 gives me 1, 1 multiplied by I, that gives me I. And then I have 2 multiplied by 1, that gives me 2I, and then 2I multiplied by I, that gives me 2I squared. Then over, so here 1, just write 1 squared plus square the number that is in front of the I, which is just 1, so I have another 1 squared. And this is going to be, I have 1, so here 2I squared, the I squared, since I is just negative root of the square root of -1, so I squared is just equal to -1. So where there's I squared, I can replace -1, which gives me that this 2 becomes -2, and then I can add I plus the 2I, which gives me 3I, over 1 squared is 1, 1 squared is 1, and then this here is just going to be equal to, so I have 1 minus 2, 1 minus 2, this gives me -1, plus 3I over 2. So this is what I get. Okay, so now I leave it there for now, and then I go to the other side, and I have 1 minus 2I over 1 plus 3I. So I'm going to rationalize by multiplying by what? It's conjugate of the denominator. And the conjugate of the denominator is just 1 minus 3I over 1 minus 3I. Okay, so this here is going to be down there, I have 1, so 1 squared. Coefficient there is just 3, so I have 3 what? 3 squared. And then on top, 1 multiplied by 1 gives me 1. 1 multiplied by -3i gives me -3i. Negative 2i multiplied by 1 gives me -2i. And then I have -2i multiplied by -3i, that gives me positive 6i squared. So where there's the squared there, I replace with what? -1. That gives me 1 minus 6. I can add the 2, that gives me -5i over 1 squared is 1, 3 squared is just 9. And this gives me, I subtract there, I get 9, I get 5, 1 minus 6 is 5. Then I have add there 5i, then over 1 plus the 10, 1 plus 9 gives me 10, like that. And then I can simplify this by dividing by 5. 5 there on top, that gives me 1 there, and there I get -I, and there I'll get what? I'll get 2. So I can simplify to this. But then what are we doing? We are adding the 2. So we're just adding the 2 complex numbers. So it means that I'm going to have negative, what I found here, which is -1 plus 3i over 2 plus, then I have that there to be what? To be -1 minus I over 1 over 2 is what I have. So since they have the same base, I'll keep the base, which is 2. 2 there, they have the same denominator, which is 2. And then I can just add what's in the numerator. And in the numerator, I have -1 plus 3i, like that. Then minus 1 minus I. So this here is going to be, I add the real numbers, -1 and minus -1, that gives me -2. Then I have 3i minus I, that gives me what? Positive 2i, then over what? Over 2. Dividing that there, here, 2 into -2 gives me -1. 2 into 2i, that gives me I. And just like that, I've expressed in the form A of A plus B I, where the A is 1 and the B also, the A is -1 and the B is 1. So there is my answer. Okay, so we move on to the next question. So the next question is telling us, let star be a binary operation on the set of real numbers defined by A star B is equal to -2b minus A, where A and B are real numbers. So the first one is saying, is star commutative on real numbers? Justify your what? Your answer. So based on this, is star commutative? So it is going to be commutative if A star B is equal to what? To B star A. If A star B is equal to B star A, then what? The operation star is what? Is commutative. So now, what is A star B? So A star B is just negative 2 B minus what? Minus A. That is A star B. And then what is B star A? So B star A is going to be negative 2. Then there I have what? I have A minus what? Minus B. So if I can get the same, if I do this and that they are equal, then it's going to be commutative. Okay, but then if I find any counter example where this does not hold, then this fails to be what? To be commutative. So I use a counter example. I'll let A be equal to 1 and I'll let B be equal to what? To 2. So let us do A star B. Let us do A star B. So A star B is just 1 star what? Star 2, and this is going to be equal to, so negative 2, my B is 2, my A is what? Is 1. So here I get negative 2. I subtract there, I'll get 1. And this just gives me negative 2, like that. And then I go B star A. B star A, I have 2 star what? Star 1, which is going to be negative 2. Then I have my A. Then I have that my A is 1. And then my what? My B is what? Is 2. So I subtract this, I get negative 2 there. Then in the exponent or in the power, I'll get negative 1. But this negative 1 there just means that that's 1 over 2 over what? Negative 2, like that. So the negative sign is going to be there. So here I got negative 2, here I got negative what? Negative half. Therefore, A star B is not equal to B star A. Thus, we have that star is not commutative, Star is not commutative. Okay, so that's how we what? How we find, or how we show that star is not what? Is not commutative. Okay, so next they're telling us to find find negative 1 star 2 star what? Star 4. So what we begin with, what is in the bracket, which is 2 star 4. This is going to be, so we're using this here, that's negative 2. My B in this case is going to be 4. My A is what? Is 2. And this is going to be negative 2. Subtract the 2 there. I'm going to have a 2. So the negatives, then here, okay, so there's a difference here between us having negative 2 like this and having the negative and the 2 like that. So this here gives you positive 4, but this here gives you negative 4. So here we'll get what? Negative 4. And then negative 4, so we go negative 1 star what? Negative 4, because this is what has remained here. And again, we go, that is negative 2. Our B is now negative 4, then minus, then our A is negative 1, like that. And then you're going to have negative 2 minus 4. This negative times negative gives me a positive, and you get negative 2. Adding the 2, you get negative 3. This is going to be, so I can write this as 1 over negative what? 2 to the power what? The power 3. So the negative, then 2 to the power 3 is just what? Just 8. So I have negative 1 over what? Over 8. Negative 1 over 8 there as our answer. Okay, move on to the next question. So the next one is telling us, let f of x be equal to the modulus of 4x minus 5 plus what? 2 be a function. So they're saying this be a function, then they're telling us to sketch the graph of what? F of x, and then also to state the range of f of x. Okay, so one thing we must know here, we're dealing with the modulus. So everything that is going to be here inside the modulus here means has to be what? Positive. We cannot get a negative value out of this. Okay, so the easy steps to sketching this is, first of all, if I say let y be equal to modulus of 4x minus 5 plus 2, like that. Okay, so I'll let it be like that. And what we need, first of all, is let us imagine if we just had modulus of 4x minus what? Minus 4. And then let's imagine what's inside there, 4x minus 5 here. This is just a line. So that's the line. And if we had, let's say if we had y equal to 4x minus what, how would we sketch that? So what we would need is the y-intercept and the what? And the x-intercept. So the y-intercept, we'll get it when x is 0. So when x is 0, we just have y to be equal to what? Negative 5. And then when y is 0, then we have what? When y is 0, we have 4x minus 5. Then we have 4x equal to 5. Then we have x equal to what? To 5 over 4. So we have this value of 5 over 4. So now, how is that going to be? So now, we have when x is 0, or I mean when y is 0, we have 5 over what? Over 4. So let's say 5 over 4 is here somewhere. And then we have negative what? Negative 5 to be somewhere here. So this means we're going to have a line that is going to pass through this point, straight line going through that point. So this here is going to be my y equal to what? 4x minus 5. That is going to be that. So now, the fact that they've put this in a modulus, it means these negative values that we have here, we can no longer have those values. We only have what? Positive values. So instead of it cutting at negative 5, it will go this side. It will reflect about what? About the x-axis. And we're going to have that. It's going to pass like that. So the negative part, okay, let's do that again. So the negative part, we have that it's going to pass like that. We'll have it like that. So meaning we'll no longer have this green part, we'll have this part and this other side also like that. So this is what we have because of what? The modulus there, because we're only getting positive what? Positive values. Now here, what they've done, there's this here plus 2. So the plus 2 there is a what? Is a vertical shift. So it's a vertical shift which is in the what? In the y-axis. So meaning that this graph or this host what has been shifted by what? 2 units in the what? In the y-axis. So at this point where it is, that is at y equal to what? To 0. So it means it has to be shifted what? 2 units up. So if that's 0, then I have 1 and 2 there. So meaning it has to start at that point there. It has to start from this point here and going what? Up like that, going up like that. So if it shifts 2 units there, meaning it will no longer cut at 5, it will cut at what? At 7 here. To cut at 7 and it goes like what? Like that. So the sketch is just going to look something like this. Let me erase this, that we have a clear view like that. Okay, so because of the modulus, we know we are going to get positive, only positive values. Then we have a vertical shift of 2, so meaning let's say our 2 is here. Here we're at 5, and then we have 7. So meaning we're going to have here, if we have that's our 5 over 4, like that, our graph is going to be here, and then it's going to go through the 7 up to there, and it's going to go that side there. Okay, so before this shift, our graph was like this. So it was passing through there up to that point and then like that. Now, because of the vertical shift there, it's going to be start from there. So this here is that's the f of x, which is just modulus of 4x minus 5 plus what? Plus 2. Okay. Next, they're telling us to state the range. So to state the range you're looking at the what? The y-axis, this axis, the y-axis, that's the x-axis. But the range you're looking at the what? The y-axis. What are the values of y are going to be getting? So the lowest value, as you can see at this point, is what? Is 2. So meaning that our range is going to be equal to, our lowest value is going to be what? 2. And 2 is going to be part of what? Part of this range, or part of the interval. And then it's going, this graph continues to go up to what? Up to infinity, all the way like that. So it's going to positive infinity like that. So this is going to be what? To be our range. Or you could write it as y greater than what? Greater than 2, like that. Okay, so our next question now is saying determine whether f of x is even or odd or neither. So to determine whether a graph is even odd, or neither, we are going to say where there's x, we put negative f of x. If we put negative, so where there's x, we put negative x. And then if we get that this here, we get back our function the way it is, we get back f of x, then it means that the function is even. Then if we say negative x and then we get negative f of x, it means that the function is what? Is odd. But if we get neither of the two, it means that the function is neither even nor odd. So let us do that. Okay, so now this means we're going to have f of x negative what? Negative x there. And then what does that mean? We have 1 minus where there is x to the power 4, we say negative x to the power 4. Then we have what? Plus negative what? Plus negative x, like that. So what is this going to be? We have negative. When I square this, I just have what? Negative 4 here will give us what? Positive, since it's a this negative x, I mean, to the power 4 will give us a positive x because we're raising it to the what? To an even power. But then there's a negative sign, so this will multiply by the negative, and we just get negative x to the power 4, and then we have positive times the negative gives me negative, like that. So now here, let us see. Did we get back this function here? Did we get back f? No, we did not get back f because this sign here is what? Is positive. Is negative, I mean. So we did not get back what? F of x. Okay, let us now factor out. Let's factor out a negative and see if maybe we got negative f of x. If I factor out a negative, I have negative there. I have positive 4. Then I have what? Positive what? X here. Okay, did I get negative f of x? No, because this here inside is not f of x. That's not f of x. So meaning that this function, therefore the function is neither what? It's neither even nor what? Nor odd. This function is neither even nor what? Nor odd. Okay, so this was the last question that we had for today. Well, if you're new, remember to hit the subscribe button and like and share to see, and visit the website to see more videos, and we'll see you in the next one.